total balance different. What I did here was I took away a channel and said convert into a stereo program pseudo synthesis.
Pseudo what?
Pseudo stereo.
So the original signal is pseudo stereo.
Yeah. No, the original signal was stereo, but I took one channel away right here.
Right.
And I told the chip to use the crystal to build the stereo signal, which it did.
Why would it do that?
Because the crystal is like resistance pass, and it has to pass through the crystalline structure, so it gives it a total balance difference between right and left channels. Here, if I take the input signal away, it can't do anything. Here, that's me. See, now if I touch the substrate, I got a different sound.
Yeah.
Right, it's not as full. Now listen. Here it changed in the top.
A little bit, yeah.
Where did you attach it this time? Back
To the dot.
Back to the dot. Yeah.
Now watch.
Yeah, it's much less.
Spinner.
It's thinner. Yeah.
See, look, no conduction. On the crystal at all. No conduction. See that?
Yeah.
Now watch when I touch here. Now watch here. Full range now. So let's touch the back.
See, that's full range as well.
Yeah, the back is full range. See? Here. No, it's different. The top is different.
Yeah, it is. Yeah. And this is what you did with all your amplifiers?
Yes.
Yeah.
That's why they could never match the balance of the amplifier. They kept saying, how did he do that with the amplifier? When they went to measure the amplifier, they couldn't measure it. How we can reverse these We can take this one off. Put this one over here. Get a different sound. Not quite the same top.
How do you know which one to put at the top?
Well, because I laid out the grid and I laid out the pattern. I said this was the input
Oh, all right.
by
All
the
right.
length. Here, so
Right.
see, watch.
So this is the one coming from here.
Yeah, there's just one
Right.
right here.
No, I was trying to see where it came from. It came from the original source. Yeah,
Yeah, this is the
of
original
which there's only
source.
one line.
Right,
So where's the input?
Right here.
right here.
And it goes
Just
red
just one line.
One line,
to that one.
one
yeah.
wire system. Here at the top. It's sort of silken like a tube.
So this is going onto that.
Yeah, I had to go into the amp, but I only got two
Oh,
wires.
okay, okay. The amp. I was forgetting the amp.
So you just have one wire coming out of the amp.
Yeah, one wire.
They, your competitors must have loved you.
They hated me. No, it wasn't that I was trying to do that. I was trying to make an electrical conductive crystal that gave the amplifier a certain sound. And I knew it was going to drive them crazy because they cut them apart at the CES shows and said, how does this damn box work? And we wouldn't tell them. And I guess Tom Bearden the whole time was laughing because he knew exactly what the crystal was and how it worked. And it's dead quiet.
Yeah, there's no hiss or background or.
But notice the instruments.
Yeah. I can hear the violins come in.
Yeah, you can hear the background of the stage. If you come over here and listen.
I mean,
It's like 3 dimensions.
Yeah.
And the amplifier doesn't care. The amplifier is just going to follow that crystal. See, what people don't understand, and I can actually demonstrate that if you want me to demonstrate it, is when you take a piece of material, right? This has unique properties to it. So can it play sound?
hold on, put that under the light.
That's just a piece of iron pyrite. But that iron pyrite's been doped by nature. So you're gonna get if it's electrically conductive, when you hook up the wires, you see all these little holes? They're all stress points. Now watch. You've got to have pretty darn good hearing. You know, audiophiles have good hearing to hear what the difference is in the musical instruments, right? But they sure couldn't figure this out. So we got to drain the amp here. And we'll just tell the rock to play it. And we'll just take what we get, right?
Okay.
Remember I showed you the properties in one of the other films when we were building a transistor.
Right. Yeah, you did.
Different sound.
Very tinny. Yeah. Nevertheless, it's conductive.
Yes. It's electrically conductive.
It's amazing.
So how would you duplicate that being an engineer, trained by a textbook,
Yeah.
how would you duplicate what the sound of my amplifier was if you had no idea what you were cutting open was going to change it? Let's go back a little bit here, Tony, so you can listen. See the violin quite
Yeah.
should be a little sharper.
Yeah, it should.
So you know that the material is electrically conductive, but it's dulling things.
Well, it's very frequency selective.
Yes, right. So if you're trying to add a dimension, you have to come up with a crystal where all the instruments, you keep your harmonics. So here. This is what took so long to figure out what the mix was and how to grow the chemical.
So what are you doing now? You're draining the amp again?
I'm going to drain the amp out because I can't move the wires unless I drain it.
Okay.
You didn't do a very good job. It's still on, so I moved it for that. I was able to move it without.
So we're
Let's
back
go
on.
back. Okay, let's go back. Okay, ready, Tony? Go back. So now the rock's out of the picture.
Yeah. We're back to the transistors in there.
Right, but what you're actually listening to is a rectification of the music.
Through the little thing
Yes.
you made, yeah.
Yes. See? Look, the monoblock goes down. Because the crystal's adding the gain. See, look.
Okay.
That's the crystal's the thing that's adding the energy. Listen.
Immediate, yeah.
So what are you switching back here?
I'm switching the loop so you can hear the real original where the gain is because there are even gains. But watch. Now it's out. You can't get anything out of it. Now, is there a pyrite? Is there a pyrite, right? It's non-conductive. Yes. Right here.
Okay.
There's no conduction here. If I take this off and put it there, you can see it just hums. Look at this. It's not conductive at all good.
Mm-hmm.
Watch this one. See, that crystal's built to add a little extra energy.
This is an iron pyrite as well?
Mm-hmm.
It's got other stuff in it now.
Yes.
Yeah.
See, people would think, well, lead, right, would dull the sound, but not necessarily. It might be brighter sound. And then you would say, well, iron pyrite would give it a tinny sound because you're looking at it, you're visualizing it, and you're saying, Well, it would be tinny.
Mm-hmm.
Just as you said, it sounds tinny.
Yeah.
So that's basically the story of the crystals. And this is what got the industry so mad, because they could not figure out how that was doing that.
Yeah.
Can you turn? Good.
So could I ask my question about
Sure.
the golden? Yeah, Tom was saying that you were finding yourself with some gold and you got warned off doing anything?
Yeah, well, I had sent I had a really good friend that worked in mines his entire life. Name was Milton. I won't give his last name. And Milton could go get something assayed.
Mm-hmm.
And so when I'd fire material, I'd grind it up and give it to him and say, Milton, go get this assayed.
Mm-hmm.
Because I wanted to know what the mix was that I was looking for here. See, because as you can see, it's not conductive on the crystal. This crystal is not conductive. See?
Right. Right.
Yet that's the path to the dots.
So it's like a facilitator or a catalyst or something to...
Yes.
Yeah.
And so I would give the material to Milton, and Milton would run away, and I always said to Milton, bring back the paperwork of what's in the material, but don't show me the assayer. So Milton would block out the name and bring back the paper assay, and there'd be 50% gold, there'd be 20% what they would call tin, or there'd be bismuth, or there'd be arsenic, and it'd be all these elements, right? And I'd say, okay, we're going to run a new batch, and I'd give him a new sample, and he'd come back and he'd say, well, there's silver and gold in this. Look, it's real high with silver and real high with gold, and these are the things that are in there. And it would go down the list all the way to 0. And it got out. It got out because it all started with Sajeka. Sajeka knew how to make gold. And Steve Worth and myself, we said, oh, well, let's just do that. Right? Well, what a mistake. I mean, they wanted to know where the mine was. They wanted to know who did this, you know, because they had never seen a material like this. In other words, in these proportions.
Mm-hmm.
And so I was pretty good with chemicals. And so I could mix the chemicals just with the background that I had. Because remember, I went around the desert and I brought back every rock that I could lay my hands on. And I could reproduce the sound out of this where there's no sound at all. And that's just something you can just go buy in a rock shop, right? I could put that in the mix and the sound would change again. But I needed a balanced sound because I was in the hi-fi industry. And so I needed a sound that caught everybody's attention, that they could hear when they were listening. You could hear the fingers on the strings.
Yeah.
Or you could hear the breath tones in the person's voice. And I said, so I kept testing materials and and every time I'd write down what I mixed and what proportion I mixed. Like a scoop of this, but I always use the same scoop. I'd say, well, I used a scoop of this, a quarter of a scoop of this, half a scoop of this, 2 scoops of this. And I'd get it tested, and when I got to this stuff that was electrical conductive, when I got to this stuff that was electrical conductive ruby gold, see the gold?
Mm-hmm.
Right here. We're looking right there.
Right.
Yeah.
When I got to that material, I had the absolute sound that I wanted. So those mixes, I can't tell you exactly what the mix is because it's proprietary.
Right.
So I want everybody to understand that. So don't call me up and ask me, because I'm not going to tell. But anyway, when I got to the mix that I wanted, I had a unique sound. And I only needed little wires to carry that sound, about number 30 wires, when I was building a power crystal, which would have been something along, and see I marked them.
Uh-huh.
Yeah.
When I was building a power crystal, if you look very closely on it, I don't know if the camera can zoom that or not, but that's what Tom Bearden referred to as a crystal under stress. Yeah, when I got to that condition, then I had the perfect crystal and the energy transfer that I wanted in the line. Because you can hear it here. This is out.
What am I listening to? No, it's not coming through.
No, it's not coming through there.
Okay.
And then I turn it on, but there's nothing there.
Yeah.
There's a gain difference here.
Yeah.
When I got to the sound that I wanted, after testing it at different shows and things, and testing people in the shop, having them sit down and listen to something, right, and they'd say, well, that's really good, that relaxes you, that makes it sound good, you know, and what I would do is I'd say, okay, that's number, 142. And I'd have that on a chart, and I'd go and I'd mix that material.
Yeah.
And I'd do a number 142 and place the dots on there and give the same test. And they could always tell. They could tell whether it was the rock or the crystal. So.
And so the gold was really a complete byproduct.
Yeah, the gold was never...
It just showed up.
It just showed up in the transmutation process, and I was never trying to make gold. I did for a little while because it's a Jacobite.
It's a fun thing to do.
Well, I learned very quick
Yeah.
that you don't make gold because there's always something wrong with that gold. And they want to know where it comes from. They want to know the exact spot that you got that gold or that silver. And let me tell you, I wasn't about to start filling out those kind of papers because what was I going to call it?
Right.
What was the name of the mine? The oven? A red powder that I was showing how to make, by a guy who collected stuff and suppressed it the entire time. There was no way around it.
Yeah.
So I sold these. So this is how I made my living for a long time with special little boxes and things, which we showed earlier. And believe me when I tell you, there was no tricks there involved. You just saw it in the whole process.
Yeah.
And you got to listen to it play. The thing is, that can you imagine this in a potted box and they can't figure out, well, how do you get the sound? It's not plugged into the wall. There's no electronic box that's changing the sound.
Right.
It's this here.
Yeah.
And it's doing it without any energy.
So they could do it by putting all the leads together, and then they could do it by putting it through your little box. It's not a mix sort of thing.
Right, exactly. So, what they did was they came in and they swamped Gary, and they bought every box he had. Of course, Gary took their money.
Right.
You know.
Who is they?
The industry.
Okay.
The speaker cable people, and they, and that's what they turned out to be, they. But the point was that they spent hundreds of dollars in Las Vegas that year on bandsaw blades trying to cut through this stuff. And of course they'd run into this, you know, and the potting material, and it would just eat the bandsaw blade out. But they would get the box apart, and then of course when they got the box apart and they saw this, whatever it was, they come running back and they said, "What is this?" And I said, "Well, there's a microscope." So Jacob had loaned me a microscope. You know, that people use with chips and doing a stereo microscope. And there, I said, right over there. I said, you didn't even have to cut the box apart. You could have went right over there to the microscope and looked at it before you wasted your money. But for years they tried different companies like Dynavector and people like this, and Advent and the rest of them tried for years to make an electronic box that plugged into the wall that simulated this, because they were going to get me. But they couldn't do it. They never knew how to do it. They never seen it done.
So you reckon they'll be trying now?
Yes, if I put them back out.
No, I mean if you put this out.
If I put that out in a box now, yes.
No, if we show this movie.
Yeah, they'll probably try.
Yeah.
You know, there's quite a procedure to it, because you have to know the exact. I only showed a few of the materials that were in there. And believe me, when it's red, and you can see that what I'm showing you is, don't look for conductivity on the crystal. It's just grown. Because there is none.
Right. They probably thought you just did a sloppy soldering job.
It has to be. It's like a semiconductive wafer.
Right.
It's an electrically conductive diode that doesn't distort the sound. Like if I put a diode in line with it, the sound is going to be clipped. I can demonstrate that if you want.
Sure.
There's a diode.
That's okay.
So, by all means, it's not the same kind of semiconductor.
Right.
See, the two are completely different. One can't generate any energy at all. It can only use energy. So, believe me, they came after me.
So what you've just managed, what you just made in the oven is to some degree self-powering.
Yes. In other words, it gets its own gain. I don't have to put any input power in it whatsoever, but you got to know exactly how to use it, and you got to have to know what to trigger it with, like this audio. And it doesn't distort the sound because it goes both ways, and it stays the same, constant.
So it's therefore taking some energy from the vacuum.
Exactly. It's a Prigogine crystal. You know, as the crystal stresses, it adds energy.
Which is to some degree what Moray was doing.
In a way.
Yeah.
But as you can see again, come up and get close. There is no electrical conductivity whatsoever. I don't care if you scrape it, and I'm scraping it.
But if you hit 3 bare places, yeah. And if you hit this, right? Yeah.
Mm-hmm. But a different sound.
Yeah. Do you know which way it travels around that thing?
Because I set it up.
I mean, is this the same as this, for example, and this the same as this, and that the same?
No, they're two different paths here.
Okay.
But they're like a Y path.
Right.
At the very top of the input of the crystal, right? You see,
That one,
it's
yeah.
long. It's short to these two paths.
Okay. Yeah.
Yeah. So in a way, Tony, you're absolutely right. This is like a Moray crystal, and we just built it for you. Except we didn't add anything to hook to an antenna,
Right.
because we weren't interested in that. We knew that already worked, because the Jacob says, well, don't waste your time. We already got that. You know, so Jacob was a funny man, because he used to run around for years that I knew him. I knew him for approximately 3 or 4 years. And he would run around and he would say, look, it's driving them crazy. They can't collect enough notes. They keep calling that guy at the Cosray Institute thinking he's going to give them the secret when he doesn't even know the secret.
Yeah.
He doesn't know how his father built it.
You think the antenna might have been just a decoy?
No.
No.
No, because what Moray built, and Sajeka used to say this, what Moray built was a self-resonating oscillator between the antenna and the ionosphere, and then he would capture that through his valve. Spatial aspect. He used to hear it come in waves, like when he started. And so Jacob knew exactly what it was. Because you can see that he filled in the book what it was.
In Sajeka's books and Sajeka's notes.
I think he said, well,
Yeah.
that Moray doped it with radium chloride. Well, of course. That's what Hubbard did.
Who?
Hubbard. The Hubbard coil.
I don't really know.
Yeah, the Hubbard coil. He did the same thing. When you do something like that and you dope it with radium chloride, you get this energy. So, I mean, even this machine, the Swiss ML, those capacitors they were doped with radium chloride.
Essentially, that was a Wimshurst machine, wasn't it?
Yes, it was. And when you get a cosmic ray hitting radium chloride, it gives off electrons.
Mm-hmm.
Which is probably why you can't get radium chloride these days.
You can't get any of that. But some people try to think that they're going to extract it
So
from
you say they dumped it on it, or daubed it with it?
Doped.
Doped it.
Just
okay.
sort of like brushed it on.
Yeah.
And so I knew that I wasn't going in that direction, because I was going in a completely different direction.
When you refer to a Prigogine crystal, that's Ilya Prigogine, the Nobel Prize winner.
Yes, it is.
He won a Nobel Prize in physics, I think.
Yes, he did.
And he died just a couple of years ago.
That's right.
Yeah.
But he knew there was energy in the stress crystal. But you need a trigger to get it out.
Yeah.
So if everybody thinks that I've just built a diode, it's sadly a mistake. So you have dimension.
Yeah. Now, is this the same principle as the machine where you were throwing things from left to right and all that?
No.
No. Okay.
base machine.
No, the base is a
That machine you showed us last time, where
interferometer.
you're taking a mono record and making it into
That's
stereo.
that's a monoblock converter.
Okay.
But
Which you've never filmed, I don't think.
no,
Yeah.
because it's not part of the energy series. It's
Right.
it's not a. It's specifically for all recordings, but this was much more important to us
Right.
because we could change the sound between the preamp and the amp. We could change the sound on the power output of the amp to the speakers. We could do a lot of different things with this.
For your manufacturing setup then, did you have a lot of people working for you?
No, I did this all by myself.
Really?
I would do maybe 500 crystals a night.
Uh-huh.
You know, boxes after boxes after box, and measure each one.
Okay.
You know, because I was the type that would work all night long.
Yeah.
I never got tired of working. I just never ran out of energy, and I didn't. Now I'm running out of energy, but energy wasn't the problem. And Tom Bearden knew it because about every 3 or 4 days you get a new tape. You know, it'd be something else that I was trying to investigate. So I think you're going to find that this is a technology that could be used for something. Well, we used it. And for years, that just drove them crazy. Tom Bearden, I think, explained in a few films that they cut the amplifiers apart. I mean, what are you going to do if you find one of these in there? What are you going to think it's for?
Right.
You know, how do you duplicate that? How do you copy that? You don't know what it is. And then when you measure it, and it's non-conductive on the crystal, you're going, wait a minute, how's the signal getting through there?
Mm-hmm.
Well, very simple. The energy is like if I have a stack of cards, one right up, like a stack of dominoes. And I hit the first domino, the second domino moves.
Mm-hmm.
But it moves with a little bit more intensity. Then it hits the third domino, and there's a little bit more intensity. And it goes, but they never fall down. They just go back and forth.
Ah.
See? So that crystal is like this, in a way.
Yeah.
And by doing that, right? By doing that, it adds just a little bit extra energy to the sound. It amplifies it a bit. And it gives it that certain sound. So, that's the story of the crystal, Tony.
Thanks a lot, John. That's absolutely fabulous.
But you got to watch it. You got to actually see how this was done.
Yeah, it's great.
And I thought the rest of them should see how it was done too. There was no trick here.
Right.
You just got to know what you're doing. And once again, I'm going to say, unless you got an imagination, you can't do it.